So I'll be talking about manipulating and cleaning data. It's a beginner-friendly talk, and I won't be doing the live code, but we'll be going through the code. So let me share the link to the repository that contains the files, then I will start. Okay, so the main reason why I chose to talk about manipulating and cleaning data is because the data that you handle in day-to-day life is really messy. And yeah, so I came across this tweet and I really liked it. So the tweet is, the first time that you're working with real data, this is what happens. So you're going unknown, you really don't know what you're doing. Then you're like, okay, let me go through the water. And woo, yeah. So that's how working with the first time you work with real data is. You really don't expect it to be so messy, have so many missing values, be very incomplete. But today I'll be taking you through what you need to do, how you can clean your data, and some of the objectives are data cleaning and manipulation. That's the general objective. Then we'll be importing our data and doing a small exploration of how you know what your data contains. Then we'll deal with missing data, finding out what data is missing, finding ways in which you can be able to fill the data, and then also duplicated data. So how do you deal with duplicated data? Then the other thing is being able to combine the different data sets and joining them together. So sometimes we have incomplete data. So like you want to do the average of data for a given school, but you only have like for one specific group of people. So you can go back to the field, collect that data, and then you'll need to merge the data together. Then the last part will be reviewing a small data set and doing the statistics and visualizations. So before I dive into what exactly the cleaning involves, I'll just take us through a bit of what you solve with data science, why we do data science, and what we need to understand before we dive into the data. So the first thing is business understanding. It's sometimes referred to as domain understanding. So you need to understand what exactly are you solving with the data. So in case you're working in a specific industry for the first time, you need to understand what the industry does and how they operate so that you can be able to now get the objectives and know what exactly you need to do with your data. Then after you've understood what your objectives are with the data, now it's time for you to understand what data you need. So you'll need to collect the data, you need to review the data. So probably you can go to Kaggle and download data sets there, or you can manually collect the data on your own. After now you've understood what the data is needed and you have all the data you need, we now go through data preparation. So that's what we're talking about today. So you already have your data. So how do you clean your data? How do you ensure you get the right values? How do you ensure when you're modeling, you have all the required parameters and everything is on set? Then the fourth thing is modeling. So drawing conclusions from your data, manipulating, creating models, regression models, linear models, etc. So being able to now create, whether use the data to predict the future using modeling. Then after now you've cleaned your data, you've created a model, you'll need to evaluate, was the model okay? Did it draw the right conclusion? Can you be able to use it in real life situations? Did it overfit? Did it underfit? Then the last part is now deploying your model. So you can use your model now in business. So an example of a use case of data is market segmentation. So in case you have a big farm and you're working to ensure that you reach your customers where they are, understand what they do with your product, etc. So you can be able to easily segment your data. So some model you can use is like k-means clustering, cluster your customers together, then now use that data to now know who are you targeting when you're marketing, let's say for school fees, or are you targeting when you're marketing for teenage things, who are you targeting when you're marketing for different genders. So that's generally the data science process. So now let's go to the data. So the first thing you're doing is importing the data. And when you are, so for us today, we'll just be using pandas, scikit-learn, and NumPy. So when you're importing, we also use matplotlib and seaborn at the end. So those are the libraries that you're using. So in case you have a library that is not there in your local machine, you can be able to just pip install and then the library name. So pip install pandas, pip install scikit-learn. So that's what you need. I think I just sent, oh, sorry. Okay, so that's the first step. So if you don't have the data sets, you can just pip install them. The libraries, you can just pip install them. The second thing is now importing the data, the libraries into your notebook. So the first thing you do is import pandas as PD, and then the dataset that we'll be using for the first part is iris. So from scikit-learn dataset, import, load iris. That's the first thing you're doing, importing the data. Then now after you've imported the data, you need to read the data. So iris, you load the dataset. So it's the same as you loading the dataset and then having the dataset in a data frame. So it's easier to read the dataset in a data frame because you can be able to see the different columns, the different rows, and how the data relates to each other. So that's the first step you're doing. Second, the next step is now being able to find some bit of information on your data frame. So for this, we'll use iris_df.info. So .info gives you a bit of information about the dataset. Oh yeah. So .info gives you a bit of information about what is contained in the dataset. So for example, we have 4 columns, and the columns we have are the sepal length, sepal width, petal length, and petal width. And each column has 150 rows, and there's no row that is empty, so they're all null. And the data type in each row is float, 64-bit floating point numbers. So that's what we get from the data set, from df.info. Once you already know what is contained in the data set, the next thing is now being able to see it in real life, like now being able to visualize what exactly you're talking about. So we'll use df.head. Without indicating the number, it will just give you automatically the top 5 values in the data set. So it just gives you the top 5 values and you're able to tell, so this is what is contained in the data set. These are the values. Yes, we already know the values are 64-bit floating numbers, but what are those? How do they look like? So these are what the values look like. So in case you want more than 5 or less, you can just indicate the amount you need and it will just give you the amount you need. Next, the other thing, you can also read from the bottom. It's not a must to get the top 3 or the top 5 values. You can also go and collect the bottom 5 or the bottom 10, whichever one you want, so that you can be able to tell whether the data is really the same or not. So this is what you use df.tail. Okay, so the other thing is now being able to find how many rows and columns we have. So we used .info, but it gave us more information, gave us the columns, the null, and the data types. But we just want to find how many rows and columns it has. So you'll just do .shape, and .shape will now give you, it has 150 rows and 4 columns. So by this, you can be able to now get an initial feel of what exactly you're dealing with. So what is your data? What does it contain? etc. Okay, so in case you have any questions, just feel free to post them on the chat. So the second part we're working on is now dealing with the null data. And in Python, there are two types of null data. So there's the none, which is a non-float missing data. This means that this missing data is not of a numerical value. So when you like add the none with integers, the value you'll get back is undefined. And then there's none. Sorry, none is not a number. So this, when you're doing arithmetic operations, the value returned will be none. So both of them just indicate missing values. They're just different in the definition, but at the end of the day, they just indicate missing values. And the scenario with missing values is you want to know whether there is null values or whether there's not, and then how you can be able to drop down the missing values and also being able to now fill in the missing values. I hope you're all on the same page. So for the first thing, let's say this is our first example. So we are using NumPy, a library in Python. It just basically stands for numerical Python. So when you run this code, you realize that all these are missing, so they don't represent any data. So the only data that is there is 0. So when you run is null, it will now give you a Boolean values of whether it's true, it's null, or false. So is or not null will just mask the values. It won't drop, it will just tell you, yes, they're there, yes, they're not. So let's run this. So is null, you'll get false for the first one. Oh, sorry, I meant to say, so the only missing values are dot none and none. So the rest, they contain values, though they're not really computable. So when you run is null, it will give you the first one it's false. So there's some data here. But this one, there's missing data. So it will be true, then false, then true. The opposite is not null. So not null will now give you the opposite result. So for true, it will replace with false. Now for false, it will replace with true. Okay. So let's go to now, how do you remove the missing values? So the first thing you can do is using drop now. Drop now will now just drop all of the missing values. So it will just remove them without really checking whether there's any other value there. So with drop now, automatically when you're using it, it will drop the rows. So this is just a series, so it will just drop the missing values. But when you're working with a two-dimensional value, you'll realize that when you use drop now, you realize it has a missing value and this has a missing value. So it will drop the entire rows. It will just remain with this. You can specify how you want your values to be dropped. So by default, it drops by rows, but you can specify you can drop by columns. So when you drop by columns, this and this will be deleted. So it will remain 7, 8, and 9. Let's check. Yeah, you remain with 7, 8, and 9. So you will define this by using axis. So axis is equals to columns. You can also, instead of saying axis is equals to columns, you can just say axis is equals to 1. You'll do the same thing. So with drop now, you can use various specifications. So there are different parameters you can use. One way Python gives us to identify the different parameters is using the question mark. So when you're unsure of like what values am I expecting, how can I remove this, what other options do I have, you can just use the question mark and it will give you now the different functions you can perform. So you can you can define the axis, you can define how you want them to be dropped, you can define the trash, the subset, and in place, what do you want to replace it with. So for example, let's use so it will give you a detailed information of how it works. So like 0 or index 1 is equals to columns. So the default is 0. And then 1 is columns. So it has many values. So you can just come, scroll, read them through. I won't go through all of them because of time, but I will go through thresh. So imagine you have these values. It's the same as the example 4 we had. So that means if you have the thresh of 3, it means it will only retain the values where 3 or more are not null. So, and then our axis is rows. So let's see what we'll get. So we will get 258. So let me explain it with something different. So let's say you want a thresh of 2 on rows. So it will mean all the rows will be returned, right? But then you don't want, let's randomly just have this as a null. So returned. So it will only return the value that have 2 or more. You can go ahead and also specify you want it to now remove only the columns. So what will we get? So this is a threshold of 2. So if we come here and have this as none, this won't be returned. It will only return the first and the third. So you can play around with how you can be able to now drop the values. So as I've mentioned, you can just use this. So in place, true. So how does it work? So you can, I think that's one assignment I'll leave you to continue working on. Okay, so now that we've dropped the values, we've seen how we can find whether they're missing. So how do we now fill them in? So let's take this example. So example 5, it's a series. So 1 and then none, 2, 9, 3. So let's say we want to fill it with 10. So you'll have to use the method fillNar. So example 5 dot fillNar and then the amount you want it to be replaced with. So you'll see it's 10. So you can still also play with this. If you want to replace it with 3, you can replace it with 3. But we have other values you can use that you can predefine. So for instance, you want it to replace with now forward fill method. Forward fill means if let me go where it's missing. So if this is 1, I will fill, if there's a missing number in front of it, I will fill with the number that's in front of it. I won't fill it with 1, I'll fill it with 2. Let's see how it works. Forward fill. Sorry, I'll fill it. Okay, I'm confused a bit. So if this is 1, I'll fill it with the number that's before it. This will be 1. Same to 2. I think I explained backward fill. So with backward fill, it's now the opposite. So I'll fill this with 3 here. And then here it will be 2. Let's see. Yeah. So the other thing is you can also define other ways to fill the missing values. So for instance, you got a class of students and you wanted to record their height, but then let's say you missed 1 or 2 students. But it's very important for you to have all the students in the class for you to have a complete value. And normally when you're in like lower classes or in your primary or high school, it's most people are of the same height in the same class. So the height differences are that huge. So you can just fill with something like the mean or the average. So this is, for example, you're filling with the mean. If you want to fill with the mean of this will be 2. That is, I hope everyone understands how to calculate the mean. So when you add the values, then divide by the total, you get the mean, and the mean will be 2. So you just fill everything with the mean. Okay. So these are just examples of how you can be able to remove. So you'll realize that as you handle bigger data sets, you'll really have plenty of missing data, and sometimes it may be very useless, so you'll just have to drop them because working without them won't cost you. But then sometimes you'll realize you'll have to fill the data so that you have complete data. So these are ways you can be able to drop the data or fill them up. So the next part you're talking about is dealing with duplicates. So sometimes you get data that is the same. So for instance, you find you filled the same person, you collected the data from the same person twice or something of that sort. So that means you'll have to either remove the duplicates or find a way to work with them. So the first thing is, how do you identify duplicates? So you use duplicated. So we're using example 6, and in example 6, with duplicated, it takes the whole row. So for here, if you're looking for duplicates, it's 0 and in the index 0 and index 2 and index 3 and 4. Those are the duplicates. So when you run the cell, you'll realize those are the 2 duplicates in the file. But sometimes you don't want to like take the duplicates of the whole row. You just want to like take specific values of the duplicates. So you'll have to define. So for instance, here we've defined it as the column letters. So you're finding duplicates in the column letters. So when you run, you'll just realize all the letters that are duplicated are removed. So like for this is duplicate. B is repeated twice, 3 times, and A is repeated twice. So meaning you'll only remain with the first 2. Okay, I think I rushed there. So let's talk about dropping the duplicates. It's simple. It's almost the same as drop now. So we'll just do the same thing. So example 6, then drop duplicates, and it will drop the numbers, the values that are duplicated. As I mentioned earlier, it drops the entire row. So unless you want to specify like which area you want them to be checked at, you'll have to specify the columns. Okay, so the other thing is now combining data sets. This mostly applies when, let's say, for example, you went collected data and you found out your data is incomplete and you need to add more data. So we have 3 main methods of combining the data sets, or let me say the data frame. So for the first one, .merge, it's mainly combined on keys. So for instance, this one we have employees. Oh, let me run this. And you realize we have employees here, and then for here it's defined, the employee is defined by the group they're in. So whether they're in the accounting department or the marketing department. But here the employee is defined by the hiring date. So what we'll be looking at are the specific keys. So like the employee names or the groups, to be able to match them together. So that's what merge does. And with merge, you can be able to join either a one-to-one join, many-to-one, or many-to-many joins. Concatenate is just adding next to it. So like if I ask you to concatenate A, B, and C, D, you'll just concatenate it to A, B, C, D. So it's not adding, but it's just adding at the end. And then combine first will now help you now splice in together overlapping data and be able to find values within one another. So let's first start with merge. So we've seen here the employee column and the employee column are the same. And if you look closely, you'll realize also the names are the same. They're just ordered differently, but they're the same thing. So when you're merging, it will automatically, just automatically merge them, depending on the name, on the ones that's the same. So Sue is in HR, Sue joined in 2018. So HR 2018. So it won't matter the order in which the columns are, but provided they're the same, they will be matched together. So you realize it's matching the common columns. Everything else that was not that was there was discarded. So we're just remaining with one column and then one taken from the first one and then the second one. Okay, the other one is many to one. So with many to one, let's take this in. You realize that each department has a supervisor. Each group has a supervisor. And when you're looking here, we have 4 people, but the groups are repeated. So like Stu and Mary are in the same group. So that means they'll have the same supervisor. So if you come and look how they joined pd.merge, you realize that they are joined by those who belong to the same group also have the same supervisor. So it doesn't matter how many the values are, provided all the values are represented. I hope that makes sense. Okay. So you realize the only thing that's added is the supervisor, but everything else the same, because the group matches the third data frame had everything until here. But the only thing matching is the group and the supervisor. So that's what was added. But then sometimes you realize you want to like specify where exactly you want to match them. So for instance, here we don't have employee, we have the name. So you have to specify what exactly you want them to be matched by. So with this, you'll use left on and right on. So like for instance, for the left on, you define the employee, which is in the first data frame. And then for the name, which is in the second data frame, but matches the employee in the first data frame. So this is what you'll get. It won't match the columns because they don't have the same name, but it will ensure that they are matching. So at the end of it, you can just drop the whole column, the name column, and just remain with the employee group and salary. But that's now how you can now be able to specify where exactly you want to match the data, especially if the column names are not the same. The other thing you can be able to do is using indexes. So you can set an index, like for here, the index to be employee. And then for the first, so I hope you remember how the first data frame looks like. So you just match it by the employee. And then also this, you set the index by employee. And when you're combining the data set, when you're defining where you want them to match, you'll have to specify that the left index is true and the right index is also true. So when you run, it will just give you the same thing, but now the indexes are defined. So employee, employee. So you'll just be adding the group name and the hire date, and anything else you want to add can be added. But we're working on the index of the employee name. Okay. So the other thing I talked about was concatenate. Concatenate, as I said, you're just adding the values. It's just adding at the end. We're not doing anything different. So like for this, if I concatenate this and this, I'll get 1, 2, 3, 4, 5, 6. So let's so 1, 2, 3, 4, 5, 6, and then the series. This is the index, and then the series will be A, B, C, D, E, F. So just them together. When you're doing, so this is just basic concatenation. I think I missed something. Oh yeah. So before I go to concatenating in Pandas, I should have talked about how you do it in NumPy, which is basically the same thing. So you just add at the end. So 1, 2, 3, then 4, 5, 6, 7, 8, 9. So concatenated. For this, which is 2-dimensional, it will just add 1, 2, 3, 4, and then 1, 2, 3, 4. Because we're adding the array twice, so it will just return the same thing. 1, 2, 1, 2, then 3, 4, 3, 4. So it's just concatenating is just adding at the end. So what about when you're working with data frames? So let's say this is the data frame you're working with, and it's indexed by the 0 and 1, and then AB is the columns. So when you add, it will just add at the bottom. It will just add new indexes at the bottom, but then the same values will be added, A, B, C, D. So one thing you can do is now ordering this. Instead of having 0, 1, 0, 1, you can order it by ignoring the index. So once you ignore the index, it will now just follow the 0, 1, 2, 3, 4. And then another thing is, so for this, the default, as I mentioned before, is normally rows. But what if you want to add them column-wise? So let's see. So it will just be the same thing, just adding next to each other. So another thing about concatenation is now dealing with joins. As we're doing here, this is an outer join. So an outer join is just adding at the end. And then if you have any missing data in the middle, it will just be replaced by none. So this is what it is. So this is the data sets that this is the data frames that we have. And from the columns, we see we have A, B, C, and then this is B, C, D. You realize here we're missing the A column and here we're missing the D column. So now when you are adding it as an outer join, it will just add none next to it. So it will be AB, it will be AD, BE, UX. Well, let me just run it so that you can be able to see it. So it will be just AD, then null values because we don't have A here. And then C, B, and C, since all the values are there, they're added. And then D, since we don't have the values of D in the first data frame, it will be none. So because of that, you can be able to join inner. So joining inner means all these that are none will be discarded. So it will only join the values that can be joined together. That means A and D, because they have null values, will be discarded, and you can only join B and C. So those are the two concatenation ways. So concatenating by inner join or outer join. One last thing, if you've done Python before, one last thing you can be able to remember is using append. And with append, it's mostly it adds at the end. So let's see what append does in pandas. So how did df9 look? So this is df9. And it's just A, B, C, D. So it will just do the same as concatenate, but with append, it just adds at the end. So you just have the same values at the end, nothing much. So those are how you can be able to join different data sets. So you can experiment with bigger data sets, how you can be able to join them together, and how you can be able to define exactly what keys are the same, so defining the indexes, defining the where to join left and the right joins, and then also the inner and outer joins, whether you just want to join the ones that are the same or you also want the ones that will give you missing values. Okay, so now that we've explored everything about what we wanted to talk about, that is being able to import and explore your data, dealing with missing data and duplicates, and being able to merge and join your data. The other part is now working on the exploratory statistics and visualization of your data. So we'll use a data frame. I think if you're familiar with data science, you've come across this data frame and this data set, and it's about a housing data set. So imagine you're moving to a new area, so in our case, Boston, and you want to determine which house you want to live in and what will be the things that will help you determine which neighborhood first, which town, and then which exact house. So some of the things that we are considering are, let's say, something like crime, that is the crime rate per town, then room, that's the average number of rooms per dwelling. So is it 2-bedroom, is it 3-bedroom? Charts, it's the Charles River Dam variable, so how many rivers are nearby. Then industry, so this is the proportion of non-retail business acres per town. Then the age, so how many houses were built before 1940, how many were built after. The other thing is now RAD, which is the access to highways. Tax is the full value property tax, tax rate per $10,000. Then the other thing is now, if you're a parent, you can consider whether how high, how low is the pupil teacher ratio. Then you can also consider the percentage of lower status proportion of the population. So if you want to live in a posh area, or you want to just live in a medium housing area, then the other thing is now the median, the MED, which is the median value of owner-occupied homes in the $1,000. So yeah, let's run the data set, we see what we have. So reading the data set, we're using pandas. I already imported pandas up there. So DF will just represent our data frame. And then with Panda, you can read the data using read_CSV. So this data set is on my repository, so I can just use the link to read it. But in case you have it on your local machine, you can also define the path that you want it to take. And then df.head, as we mentioned earlier, it will help you now read the first 5 values of the data set. So this is what we get. These are the values. And yeah, so the first thing is we want to know what is the shape of our data set. How many columns, how many rows do we have? We have 506 rows and 13 columns. So I want more information. Do we have missing values? What are the values of the, what are the data types? So for now, all the values are non-missing. So we don't have any missing data. And all the data types are float, so we're just dealing with numbers. Okay, so another thing you can use is .describe. Describe now helps you do multiple arithmetic operations. So for example, this is the median value of a house, and we want to do the mean. So, okay, so you want to do the mean. So you'll have to define the data set and then the column and define the mean. So it will give that. If you want to find the median age, you can also do the same. But then remember, all this you might not really, you might find it hectic to do for each value because you have like 13 columns and all these 506 rows. So imagine you want to find the mean of each and every column and the mean of each, the median of each and every row, the average. So it will take you a while. So the easiest way is to do describe. The describe gives you one, the count, which is now how many rows are there. Then the mean value per row. So you can be able to, let's say, for example, the age, the median, the mean of the age is 68. Then the other thing you can be able to tell the standard deviation. So standard deviation, and then the mean and the max. So what is the minimum age? And let's see, the minimum age is 2.9, maximum age is 100. And then now what is the lower quartile, the upper quartile, and then the average. So what is the average? So like for age, the average is 77. You see, it's easier to use the describe to find all the statistics you need instead of just doing them individually. And you can be able to now really look at what values you have. Like for instance, here, the charts, that's the Charles River Dam. The minimum value is 0, and most of the values are 0, and then the maximum is 1. meaning the range is below 1. So it can be the range they're using is 1, but then you realize most of the values, none of them is above 1. It's very few that are above 1. So you can now be able to get a bigger picture of your data. The other thing is now being able to find the relationship between, this is a spelling error, finding the relationship between different columns. So this we use group by, and by group by you can be able to find like the relationship between age and the median value, and then the mean. So group by age, and then find the median value, the mean of the median value. So people who are age, the houses that are 2.9 years, the median value is 26.0. Okay, then since we're running out of time, let me just skip a bit. You can on the GitHub page you can find all the values, but let me just skip a bit. So value counts enables you to now count how many values are there. So for instance, with an error in the last. Oh yeah, I should have done this first. So this, we're grouping them by applying a lambda, a function. So the function is for houses that are above age 50. So define, give the age. So we're like telling them if there's a house above 50, say it's true. The age is above 50, say it's true. If it's below, say it's false. So we now want to find the value counts. Value counts now will now tell us how many are true and how many are false. So that's what it gives us. So you can go and experiment with group by, go and experiment with value counts, and be able to, and also lambda, to be able to now do different operations on the different values. So maybe I can just do one or two plots. So the first one you can do is chas. So chas was, I don't remember. Let me check. A minute. Yeah, chas was the Charles River dummy, and we realized that so we want to find how many are non-unique and how many values are unique. So non-unique gives us the amount of unique values. So are there any unique values? Are there, how many are they? Then unique gives us now the values themselves. And now you can do a value count of it. So it give you the only two unique values, that's 0 and 1. And with 0, you get 471 as 0, and then 1, it's 35. So from there, you can now do graph with it. So the first thing graph you can do is a bar graph, and you can be able to plot a bar graph and see what is the relation between the two. The others, you can be able to just go to the repository and see the other different graphs that are there. So there's like the correlation, so being able to tell how the different values are correlated. Are they negatively correlated? Are they positively? Are they highly correlated? Are they lowly correlated? You can even be able to now sort them by do a correlation of a specific value. So yeah, I don't think I can take any more of your time. So thank you so much for joining me. Go ahead and experiment with the remaining visualizations using heat maps, using histograms, how they look like. So be able to, so this is just a correlation with, but with heat maps. So you can be able to just visualize instead of looking at numbers. So go experiment which visualizations you can use to see. Thank you so much. Let me just give you a takeaway. So when data science scientists look at data set, it's just a bunch of numbers, but really visualizations help us to now find the correlation between the numbers. And when you're cleaning and manipulating your data, you can be able to now figure out what you need, how the data are related, and be able to find insights from your data. Thank you so much. And I give it back to you, Maria.
Thank you, Bethany. Thank you so much. It was a great session. I see that we do have one question. I think the question is, can we guess or forecast some missing points in the data set?
So as I said, you can fill missing data, the missing data with any value that you want. So you can be able to tell. So when you're already describing your data, like for the chess, we realize it's only ones and zeros. So if you find like one is missing, it's very easy for you to just replace it with a 1 or 0. So you can just find the ratio or the mean and then just replace it there with ones and zeros. So yeah, you can be able to just forecast, but make sure you have the business understanding in mind why you need to replace with it, and also ensure you can be able to justify why you did that. So being able to understand your data and finding the reason why you did that. Yeah.
Thank you. I don't think we have any further question. Just wanted to let you know that I shared the link to the event survey. So if you can dedicate a minute or two to fill it out and just share your feedback, that will be great. I also mentioned that the recording will be available in a few days. Usually takes about 2 days until it is uploaded on our YouTube channel, and I shared the link there as well. So yeah, I don't think that we have any further questions, so we can close this session for today. Thank you everyone for joining us. Thank you, Bethany, and we hope to see you again in one of our next events.
Thank you so much. Hope to see you again too.